The morning of December 1944 is cold, a biting, damp frost clinging to the steel hulls of the 2nd Panzer Division. Inside the cramped, gasoline-scented interior of a Panzer IV, the commander peers through his cupola. For years, the German tankers have been told that the American M4 Sherman is a Ronson, a lighter that burns on the first strike. They have seen them brew up in the sands of North Africa and the bocage of Normandy. To the veteran German crews, the Sherman is a thin-skinned, tall target, an inferior machine aboard a nation that values comfort over combat power. But then, the horizon begins to move. It isn't just one Sherman, or 5, or 10. Out of the tree line, dozens of the rounded, olive-drab silhouettes emerge, their engines a synchronized low-frequency hum that vibrates the very ground. The German gunner lines up his sights, fires, and watches a Sherman erupt in a spectacular geyser flame. He smiles, but the smile fades. Before the smoke even clears, 2 more Shermans have already crested the ridge to take its place. Behind them, dozens more follow, moving with a terrifying mechanical indifference. The German commander realizes with a sudden, sinking dread that they are not fighting a vehicle. They are fighting a tide. For every Sherman they destroy, the Americans seem to have 1,000 more waiting in the hold of a ship, and the laughing stops. By the summer of 1940, the world was in a state of collective shock. The German Wehrmacht had shattered the French army, arguably the most powerful land force in Europe, in a mere 6 weeks. At the heart of this victory was the Panzerwaffe, the armored force. These were not yet the heavy Tigers or Panthers that would later haunt Allied nightmares. They were mostly light Panzer IIs and medium Panzer IIIs. However, their doctrine of Bugangskrieg, or maneuver warfare, had redefined the battlefield. To the observers in Washington, D.C., the message was loud and clear. The age of the horse and the static trench was dead. The future was steel, and the United States was dangerously behind. In 1940, the U.S. Army was ranked roughly 19th in the world in terms of size, trailing behind even small European nations. Its armored force was practically non-existent, consisting of a handful of outdated light tanks and a fragmented command structure. The American military establishment was a sleeping giant, but its awakening was chaotic. While the Germans were refining their veteran crews in the fires of the Eastern Front, American engineers were staring at blank blueprints. They didn't just need a tank. They needed an entire ecosystem of armored warfare that could be exported across 3,000 miles of the Atlantic Ocean. This geographical reality, the oceanic hurdle, would dictate every bolt and weld of the American design philosophy. The Germans viewed the tank as a duelist, a high-performance, specialized weapon designed to destroy its opposite number. This led to an engineering culture that prioritized over-engineering. Every German tank was a masterpiece of artisanal manufacturing, often requiring thousands of man-hours of hand-fitting. The American approach, born from the assembly lines of Detroit and the philosophy of Henry Ford, was fundamentally different. To the Americans, the tank was a piece of industrial equipment. It had to be reliable, it had to be easy to repair, and most importantly, it had to fit on a standard transport ship. In 1941, as the first prototypes of what would become the M4 Sherman began to take shape, the U.S. Army held the Louisiana Maneuvers, a massive series of war games designed to test their new theories of mobile warfare. It was here that the blueprint for the arsenal of democracy was solidified. The Americans realized they couldn't afford a Tiger, a 60-ton behemoth that would break every bridge it crossed and require specialized cranes to lift onto a ship. They needed a 30-ton workhorse. They needed a tank that could be mass-produced by laborers who had previously built refrigerators and sedans. While the Germans celebrated the individual prowess of their tank aces like Michael Whitman, the Americans were focused on the mean time between failure. They knew that a tank sitting in a repair shop, because its complex interleaved wheels were jammed with frozen mud, was a tank that wasn't on the firing line. The Sherman was designed with a vertical volute spring suspension VVSS that could be replaced in the field with basic tools. Its engine, a Continental R975 radial originally designed for aircraft, was loud and thirsty, but was remarkably reliable. By the time the first Shermans arrived in North Africa in 1942 for the Battle of El Alamein, the Germans were about to face a logistical reality they were fundamentally unprepared to match. The stage was set for a clash between the Teutonic sword and the American hammer. Every German victory in the early years had been won through superior coordination and speed. But as the war progressed, the German high command became obsessed with heavier armor and bigger guns, ignoring the crumbling infrastructure beneath them. Meanwhile, the Americans were standardizing every nut, bolt, and shell. They were building a machine that could not only fight, but could be sustained indefinitely on a different continent. As the first Shermans rolled off the lines at the Chrysler-Detroit Arsenal, the American industrial machine was just beginning to warm up, preparing a deluge of steel that would eventually drown the Third Reich's dreams of quality over quantity. While the German high command was fixated on the Wunderwaffe, the wonder weapons, the American military was obsessing over the Liberty ship. The M4 Sherman was not merely a tank, it was a payload. Every design choice was dictated by the physical constraints of the 10,000-ton cargo vessels that had to ferry these machines across the U-boat-infested Atlantic. If a tank was too wide for a standard rail car or too heavy for a ship's heavy-lift boom, it was useless to the war effort. This forced American engineers into a discipline of modularity that the Germans, in their pursuit of the perfect fighting machine, completely ignored. In the factories of Michigan, Ohio, and Pennsylvania, the Sherman was being birthed at a rate that defied military logic. By 1943, the Chrysler-Detroit tank arsenal alone was producing more tanks per month than the entire German industry combined. The Americans weren't just building tanks. They were building a universal platform. The M4 hull was designed to be adaptable. It could be fitted with a 75mm gun for infantry support, a 76mm high-velocity gun for tank-to-tank combat, or even a 105mm howitzer for bunker busting. This standardization meant that a crew from a disabled tank in the hedgerows of Normandy could hop into a replacement tank delivered that same afternoon and find every switch, lever, and shell rack in the exact same place. The German logistical situation was a mirror image of this efficiency. By 1943, the Wehrmacht was operating a mechanical zoo. They had the Panzer III, the Panzer IV, the Tiger Eye, and the newly arriving Panther. Each of these vehicles used different engines, different transmissions, and different tracks. Even within a single model, like the Panther, there were constant rolling changes on the assembly line. A fuel pump for a Panther built in May might not fit a Panther built in June. On the Eastern Front, this was a disaster. On the Western Front, it would become a death sentence. When a German tank broke a drive sprocket, it often had to be abandoned or towed back to Germany for repairs. When a Sherman broke, a mechanic with a wrench and a spare part from a nearby depot had it running by sunset. The Americans also pioneered the maintenance battalion. Every U.S. Armored Division traveled a massive tail of specialized repair vehicles, mobile welding shops, and recovery vehicles like the M32 tank recovery vehicle. These men were the unsung heroes of the Sherman success. They operated under a cannibalization doctrine. If two Shermans were knocked out, they would strip parts from one to make the other functional within hours. The Germans, meanwhile, relied on the heavy lift capacity of their specialized Brigitte recovery tanks, which were so few in number that they often broke down just trying to tow their comrades. This disparity created a psychological shift on the front lines. The German tanker knew that his vehicle was a precious, irreplaceable asset of the Reich. If he lost it, he was likely relegated to the infantry. The American tanker knew his vehicle was a tool. This allowed for a more aggressive, high-tempo style of warfare. The U.S. Army could afford to take risks because they knew the industrial pipeline behind them was never-ending. By the time the Allies began planning for Operation Overlord, the invasion of Normandy, the M4 Sherman was more than just an armored vehicle. It was a physical manifestation of a global supply chain that the Germans could not even visualize, let alone disrupt. As the summer of 1944 approached, the German intelligence reports began to filter back to Berlin. They spoke of endless columns of American steel. The German veterans, hardened by years of fighting Soviet T-34s, initially scoffed. They believed their superior optics, thicker armor, and high-velocity 88mm guns would turn the Sherman into scrap metal. They were right about the individual engagements, but they were tragically wrong about the nature of the war they were about to enter. They were about to learn that in modern conflict, a broken tank that could be fixed is worth 10 perfect, tanks that are stuck in the mud. To understand why the German Panzers froze, one must look beyond the armor thickness and gun caliber. From a tactical angle, the Sherman possessed a hidden gem of engineering that the Germans never mastered: the gyro stabilizer. This primitive but effective system allowed the Sherman's 75mm gun to remain relatively level while the tank moved over uneven terrain. While German gunners, despite their world-class ice optics, had to bring their Panzers to a complete halt to fire accurately, a Sherman could fire while closing the distance. In the high-stakes world of armored combat, the tank that gets the first shot off usually wins. The Sherman's ability to fire on the move, or at least faster upon halting, meant that American crews often blinded German tanks with high explosive rounds before the Germans could even traverse their heavy turrets. Furthermore, the Sherman's turret traverse speed was a tactical revelation. Powered by a rapid hydraulic system, the M4 could swing its gun 360 degrees in approximately 15 seconds. By contrast, the mighty German Panther or Tiger often relied on a slower power takeoff in the engine, if the engine wasn't revving high. The turret moved at a crawl. In the close quarter fighting of the French hedgerows, Shermans could outspin their heavier opponents, flanking them before the German gunner could bring his sights to bear. From a human angle, the disparity was even more profound. The Sherman was designed with crew survival as a priority, a philosophy that ran counter to victory or death ethos of the SS Panzer divisions. The M4 featured more hatches and a more spacious interior than almost any contemporary tank. When a Sherman was hit, its crew had a significantly higher chance of escaping than their German counterparts. Late war wet stowage models further reduced the risk of ammunition fires, the dreaded brewing up, by surrounding the shells with a mixture of water and glycerin. Statistically, for every Sherman lost, only one crew member was typically killed, compared to much higher attrition rates in German or Soviet tanks. This meant the U.S. Army retained its most valuable asset: experienced veteran crews. A German ace might destroy 10 Shermans, but if he lost his Tiger once, he and his highly trained crew were likely dead or captured. The American tanker, having bailed out a burning M4, was often back in a new tank within 48 hours, carrying his combat experience with him. From a technological angle, the German Panzer was often a victim of its own sophistication. German engineering favored the interleaved road wheel system, known as Schachtel work. While this provided a smoother ride and a more stable firing platform, it was a mechanical nightmare in the field. If an inner wheel was damaged or a bearing seized, mechanics had to remove several outer wheels just to reach the problem. In the freezing slush of the Ardennes or the thick mud of the Lorraine, this mud would pack between the wheels and freeze solid overnight, literally anchoring the Panzers to the spot. The Sherman, using its simpler vertical volute spring suspension, was open and accessible. An American crew could knock frozen mud out with a crowbar in minutes, while a Tiger crew might spend hours with a blowtorch just to get their tracks a turn. This leads directly to the enemy angle, the perspective of the German soldier looking through his periscope at an American advance. Initially, German intelligence dismissed the Sherman as second-rate, but by late 1944, the tone of German after-action reports shifted from mockery to alarm. They weren't just seeing tanks. They were seeing a relentless logistical monster. German commanders noted with frustration that American artillery was on call and integrated directly with tank platoons via high-quality FM radios, standard equipment in every Sherman. If a German 88mm anti-tank gun opened fire, the Shermans didn't just fire back. They used their radios to call in a 105mm battery that would level the entire tree line within 3 minutes. The Germans realized they were fighting a combined arms machine where the tank was just one part of a terrifyingly efficient whole. A German tanker could be the best marksman in the world, but he was fighting a foe that had infinite ammunition, superior communication, and a repair system that seemed like black magic. Captured German documents revealed a growing psychological fatigue. They described the Sherman swarm as an unbreakable force. No matter how many they killed, the horizon was always full. The realization began to dawn on the veteran Panzertruppen. They were being outproduced, outrepaired, and outorganized. The toy they had laughed at in 1942 had become the instrument of their inevitable destruction. This industrial pressure created a freezing effect on German strategy. Commanders became hesitant to commit their heavy tanks to breakthroughs, fearing that any mechanical breakdown or minor battle damage would result in the total loss of the vehicle. The Sherman's greatest weapon wasn't its gun, it was its presence. Its ability to be everywhere at once meant the Germans could never concentrate their dwindling resources in one place for long. The American tank wasn't just a vehicle. It was a symptom of a collapsing Reich. The true turning point in the psychological and tactical war between the Panzer and the Sherman arrived in July 1944, during Operation Cobra. For weeks, the Allied advance had been suffocated by the Norman bocage, dense, ancient hedgerows that turned every field into a natural fortress. The Germans believed they could hold the Allies in this green hell indefinitely. They had positioned their elite panzer divisions, including the 2nd SS Panzer and the Panzerlehr, to block the roads. But the Americans didn't just push through. They shattered the line with a level of mechanical violence the Germans had never witnessed. As the carpet bombing of the St. Lo sector ceased, hundreds of M4 Shermans, many fitted with improvised Cullen hedgerow cutters, steel tusks welded to their fronts using scrap metal from German beach obstacles, charged into the gaps. This was the moment the Sherman's reliability became a strategic weapon. While the German panzers were forced to move only at night to avoid Allied air power, and even then suffered frequent mechanical failures, the Shermans kept their engines running for days on end. The breakout turned into a race. The German crews were paralyzed. They would knock out a lead Sherman, only to see the following tanks simply bypass the wreck by crashing through a 5-foot-thick stone wall that the Germans assumed was impassable. General George S. Patton's Third Army utilized the Sherman's speed and fuel efficiency to execute a giant pincer movement. The German 7th Army found themselves trapped in what became known as the Falaise Pocket. Here, the superior panzer became a liability. Thousands of Panthers and Tigers were not lost to American shells, but to their own complexity. As they ran out of fuel or suffered minor transmission failures during the retreat, their crews were forced to set them on fire and abandon them. The roads of Normandy were soon littered with the abandoned husks of Germany's finest engineering, while the inferior Shermans continued to roll at 25 miles per hour toward the German border. The German High Command was in a state of shock. They had expected a slow, methodical battle of attrition. Instead, they were being overrun by a motorized army that didn't seem to need to stop for breath. The ultimate proof of the Shermans' dominance occurred in September 1944, near the French town of Ericourt. This was not a battle of ambushes in the woods, but a large-scale, open-field tank battle. The exact kind of engagement where the German Panther, with its long-range 75mm KWK-42 gun, was supposed to reign supreme. Hitler had ordered a massive counteroffensive to blunt Patton's drive to the Rhine, committing the 5th Panzer Army, equipped with the latest Panther tanks, to wipe out the U.S. 4th Armored Division. The Germans held every, on paper, advantage. The Panther's front armor was nearly impervious to the standard 75mm Sherman gun at long range. However, as the morning mist rose over the Lorraine hills, the toy tanks of the U.S. Army executed a tactical masterclass. Utilizing their superior radio coordination, the Shermans moved in small, aggressive groups. While one platoon of Shermans engaged the Panthers from the front, distracting the German gunners, another platoon used their superior mobility to flank the German columns through the rolling terrain. What followed was a slaughter. The German crews, many of whom were poorly trained replacements rushed to the front, found themselves frozen by the speed of the American response. The Sherman's fast turret traverse allowed them to snap fire at the thin side armor of the Panthers before the Germans could even turn their hulls to face the threat. In just 11 days of fighting, the Americans lost roughly 25 tanks. The Germans, however, lost over 200, including nearly 150 of their superior Panthers. The Battle of Ericourt shattered the myth of German qualitative superiority. It proved that a reliable, well-manned, and well-supported tank, like the Sherman, was a far more effective weapon of war than a heavy, temperamental masterpiece. The Germans realized that the American industrial machine hadn't just produced more tanks, it had produced a better system of warfare. By the time the remnants of the 5th Panzer Army retreated, the morale of the Panzerwaffe was broken. They no longer saw the Sherman as a weak opponent to be laughed at. They saw it as a relentless, ubiquitous predator that couldn't be stopped by mere steel. By the winter of 1944 and the early months of 1945, the roads leading into the heart of the Reich had become a graveyard for German ambition. The disparity between the American and German armored forces was no longer a matter of tactical debate. It was a visible, physical reality. Visitors to the front lines during this period would witness a bizarre sight. Miles of abandoned German armor, often in pristine condition, left by the sides of the road. These were not casualties of shells or rockets, but casualties of a collapsed logistical spine. The German strategy of building heavy had finally backfired. As the Allied air forces intensified their campaign against German oil refineries and rail hubs, the Panzers became stationary pillboxes. A Tiger II, weighing nearly 70 tons, consumed staggering amounts of fuel that the Reich no longer possessed. When a Tiger ran dry, it stayed where it was. Because the Germans had never standardized their recovery equipment to handle such weight, these monsters were often scuttled by their own crews. In contrast, the Sherman's modest weight and high mechanical reliability meant that even as the Allied supply line stretched hundreds of miles from the French coast, the tanks kept moving. The numbers told a story of industrial annihilation. While Germany struggled to produce a few hundred Panthers a month in factories under constant bombardment, the United States was shipping thousands of M4s in every configuration imaginable. The tank graveyards of the Ardennes and the Rhineland were filled with German machines that had simply reached their mechanical limit. The American maintenance companies followed close behind the front lines, stripping these graveyards for intelligence and occasionally using the superior German 88mm optics for study. But the most significant find for American intelligence was the state of the German crews. They were exhausted, undersupplied, and increasingly terrified of the Shermans' omnipresence. Reports from the U.S. 1st and 3rd Armies noted that toward the end, German infantry would often surrender the moment American armor appeared, knowing that no Panzer reinforcements were coming. The quality that the Germans had gambled on had failed to produce the one thing they needed most, a sustained presence on the battlefield. The Sherman, despite its perceived flaws, had achieved the ultimate military objective. It occupied the ground and held it. As the Allied armies crossed the Rhine, the true extent of the American industrial victory became visible. It wasn't just that the Shermans were more numerous. It was that they were part of the seamless, globalized machinery of war. By 1945, the M4 had been upgraded to the EZ-8, M4A3E8 variant, featuring wider tracks for better mud flotation and a high-velocity 76mm gun that could penetrate the front of a Tiger at combat ranges. The technical gap the Germans had relied on for 3 years had vanished, but the German logistical gap had widened into a chasm. In the final months, the German Panzerwaffe suffered a psychological breakdown. German tankers began to report Sherman phobia, a dread not of a single tank, but a tactical system the Sherman represented. If a Panther engaged a Sherman, it knew that within minutes, American Grasshopper observation planes would be circling overhead, directing 155mm long-tom artillery onto their position. The Sherman was the finger of a giant, and wherever it pointed, destruction followed. The post-war analysis by the U.S. Army's Ballistic Research Lab confirmed what the tankers had felt. The Sherman was the most efficient tank of the war. While the Soviet T-34 had a higher loss rate due to poor ergonomics and lack of radios, and the German tanks had higher mechanical failure rates, the Sherman sat in the Goldilocks zone of warfare. It was reliable enough to travel 1,000 miles across Europe, lethal enough to win at Aircourt, and safe enough to keep its crews alive to fight another day. When the war ended in May 1945, the Sherman didn't just disappear. Because of its modular design and the sheer volume of spare parts available, it became the backbone of dozens of post-war militaries. From the Israeli Defense Forces to the armies of South America, the Sherman continued to fight for decades. The Germans, meanwhile, were left with mountains of high-tech scrap metal, magnificent machines that were, in the final accounting, too heavy and too complex to save the regime that built them. The Tiger had been a toy for an elite few. The Sherman was a tool for a global superpower. History often remembers the greatest weapons as those with the thickest armor, the longest range, or the most terrifying reputation. In the annals of World War II, the Tiger and the Panther hold that dark prestige. They were the apex predators of the 1940s, engineering marvels that pushed the limits of what steel and internal combustion could achieve. But as the smoke cleared over a broken Europe, a different lesson emerged from the ruins, one that changed the nature of warfare forever. The war was not won by the most complex machine, but by the most effective system. The M4 Sherman was a physical embodiment of a new kind of power, industrial consensus. It was a tank designed by committee, built by mass production laborers, and sustained by a logistical network that spanned half the globe. It proved that a weapon's value is not measured solely by its performance in a one-on-one duel, but by its availability, its reliability, and its ability to be integrated into a larger, multi-domain force. The German Panzers froze, not because they were outgunned in every instance, but because they were outthought by a nation that viewed war as a problem of management and flow. We often think of victory as a series of heroic moments on the battlefield, but the story of the Sherman suggests that victory is often decided years earlier on the drafting boards and assembly lines. The Sherman taught the world that quantity has a quality all its own, not through the mindless sacrifice of men, but through the overwhelming application of resources. It remains a testament to the idea that the greatest strength of a democracy is not its ability to produce a single masterpiece, but its capacity to produce a relentless, unbreakable tide of good enough. In the end, the German tankers who laughed at the first Shermans they saw were right about one thing. The M4 was a simple machine, but they were fatally wrong about the significance of that simplicity. The Sherman didn't need to be a masterpiece. It just needed to work. Every time, everywhere. As the sun set on the Third Reich, the olive-drab silhouettes of the Sherman stood as a monument to a simple, devastating truth. You can build the finest sword in the world, but you cannot win against a man who builds 1,000 hammers.